So, let's practice these. Keep your hands to yourself there. Okay. Do me a favor, put away your monatomic on papers.
Can we just flip them over? Like,
Just have a pre-act table out in front of you.
Oh,
Okay.
even the one that has the pluses and minuses on it?
Yeah, you can, for now, you can do
I'll
that.
just get mine 81 out.
I'm not even gonna have one.
For the quiz, you'll have a pre-act table in front of you.
Okay.
Alright, you guys ready?
Mm-hmm.
Equal N -3.
It's,
Non-metals, the end with
it's nitrite.
ite, nitrite.
Yeah.
Alright, good. Alright, now ferric. When you're doing the metals, stop for a moment, think of what are the two common charges for it. Iron has what two common charges?
Plus 2 and
Plus
plus
2
3.
and plus 3.
Plus 2 and plus 3. Now look at the name, ick.
Mm-hmm.
That is the
Higher one.
higher charge. So therefore, which
Plus
iron is that?
FE3.
That's Fe+3, also called iron,
Aye.
okay? Iron 3 or Fe+3. Alright? Lead, what are the two common charges for lead?
Plus
Plus 2
2 and
and
plus
plus
2
4.
plus 4.
Up here, yep.
Yeah,
It's one of
plus
those
4.
kind of odd exceptions here,
Oh, so it's
2
just-
and 4. So this is the +2, so which, it's the lower of the two charges, so which one is this one?
IOS.
lead.
Or,
Lead?
No, it's not lead, is it?
Yeah, PB is
yeah,
lead,
it's lead.
but it's lead what? Roman numeral.
Lead 2.
Lead 2, or
Lead.
Used to be called plumbum.
Or it's,
Columbus.
Columbus. This is Columbus,
Columbus.
not Columbus.
Columbus.
Okay, manganic, what are the two common charges for manganese?
it's plus 1 and, no, it's plus 2 plus 2.
Positive
that's
2 and
wrong.
positive,
Plus 2 plus 3.
positive 2, positive 3. Remember, the two that have the exceptions are
Mercury.
1 and 4. 4, tin and lead, positive 1, copper and mercury.
I was thinking mercury.
So that's gonna be,
Otherwise, everything's 2 and 3. Okay,
so is this manganese, like,
3.
okay. So this is manganese 3, and the formula would be Mn,
And then positive 3.
Mn positive 3. And it's kind of easy because this will be the same as the charge right here, with the exception of that 1 mercury, 1. Okay, oxide.
Negative.
Oxygen's group 16.
Negative 3.
Negative 2.
Negative 2, sorry.
Oh, negative 2. Remember, 0, negative 1, negative 2, negative 3, negative 4. So O negative 2. H negative 1.
That's a hydrogen.
Hydride.
It's
If,
Hydride.
if it has a negative charge, it's ide. It's always ide.
hydrogen.
Hydride. Alright, what are the two charges for manganese?
Plus 2 plus
Plus
2.
2 plus 3.
2 and 3. So this one is a positive 2, which is
Manganese.
manganese, or manganese.
Manganese 1, 2.
2.
Manganese 2.
And then plus
Manganese, good. F negative 1 is called
Fluoride.
fluoride, good. Alright, Cr positive 2, what are the two charges for chromium?
2 and 4. No, 2
Two
and
and
3.
3.
2 and 3. This is lower charge, so this is
This is chrominus.
chromis.
Chromis,
Okay.
and then
Or chromium 2. O negative 2,
oxide.
oxide. Alright, two charges for cobalt,
It's
Plus 2 and plus 3.
2 and 3. This is the lower one, so this is
cobus.
Cobus.
cobaltus. Yeah.
Cobalt. Oh, it's cobaltus.
Mhm. So cobalt 2 or cobaltus. I negative 1,
Iodide.
Iodide.
iodide. Sounds weird. I died. S negative 2,
Sulfide.
sulfide. Phosphide.
That's
Oh, that's
negative.
F or PH. negative something.
No, it's
P.
negative
P.
3.
P.
Negative 3.
P negative 3.
Negative 3.
It's a group 15, so it has a negative 3 charge. Cl negative 1?
Chloride.
Chloride, good. Fluoride? Group 17,
Negative 2.
Negative
FL,
1.
negative
negative 1. Remember, 0, negative 1, negative 2, negative 3, negative 4.
We know.
So that's negative 1. Mercuric. What are the two charges for mercury?
Hg plus 2.
Plus 1, plus 2.
Hg.
Plus 1, positive
So
2.
this is the positive 2.
Yes, without the
So I-
subscript.
Right.
Yeah, without the
Mercury 2, Hg positive 2. Good. What are the two charges for chromium?
Plus 2.
2 and
This is
3.
chromic.
2 and 3. So this is a higher one. Which one is it?
Chromic.
Chromic, or chromium 3. Well, two charges for manganese?
2 and 3.
2 and 3. So the higher one. So this is
Manganic.
manganic, or manganese 3. Two charges for iron?
Plus 2, plus 3.
2 and 3. This is OUS, so this is which one?
Two.
Fu plus 2.
This is the lower charge. Good.
Iron.
Br negative 1?
Bromide.
Bromide.
Bromide, good. Okay, two charges for chromium,
2 and 3.
Plus 2, plus 3.
2 and 3. So which one is this one?
CH plus 3.
Chromium 3.
Chromium 3. Cr positive 3. Hg2 positive 2.
This is mercury.
Mercury 1.
This is mercury 1, or mercur,
Mercury.
mercurus, not marcarena. No dancing here. Alright, Cu positive 1.
This is cuprous. Cuprous.
Okay. Thing is, if it's gonna be a positive 1, that's always gonna be the lowest one. So it's always gonna be an OUS. So copper 1 or cuprous. Cobaltic.
Plus
What are the
3.
two charges for cobalt?
3, 2. Cobalt 3.
So CO3.
So this is your higher one. Cobalt 3. Sulfide.
This is negative 2.
Good.
S negative 2.
Alright. Sn positive 4. Two charges for tin.
This is
2 and 4.
2 and 4. Okay, so this is, used to be called stannum.
Stanic.
Stannic. Or 10-4. Like radio talk.
10 4.
Stannic. Okay. Bromide.
this is negative 1. B.
Group
B1
17.
negative 1.
Yep, there you go. Group 17, negative 1. Two charges for copper.
This is
2
and
3.
2
and 1. 1 and 2.
1 and 2.
Oh, yeah, 1 and 2.
Okay. It's one of those.
Cupric.
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 So this is the higher of the two charges. So this is cupric.
Copper
I like this better than elements.
P negative 3. Called
Phosphide.
phosphide. You like this one better than elements?
Yes.
Well,
Why
now
is
we
that?
know the elements,
I don't know, it's
so
cool.
it's not as hard.
Yeah, and that's the
Makes
reason
sense
why
more.
I go over elements first, because this is
Yeah.
a stepping stone for this.
It makes me sound smart when I say them.
And eventually you get to the point where if you ever read like the ingredients on a cereal box or something like that,
That's phosphide.
you'll start recognizing the substances that are within that.
Okay.
Yeah.
I'm gonna be at the
Or-
store and mom will be like, what?
Mhm.
I'm like, that's phosphide.
Stannic, okay, what are the two charges for 10?
Oh, it's positive 4 and positive 2.
Okay, so this is IC, so which one is this one?
SB.
SB
2?
4 plus 4.
Oh yeah.
This is
four.
higher than
Never
two
mind.
charges. 10-4, I said positive 4. Two charges for iron?
2 and 3.
2 and 3. So which one is this one?
Ferrous.
Ferrous.
Or iron 2? Cupric, what are the two charges for copper?
1 and 4.
1 and 2.
2.
1 and 2. So which one is this one?
This is
Two.
copper.
This is
Copper.
Copper 2.
This is copper
Ah, you
2.
got me on 4, so you said 1 and 4.
Hg positive 2. What are the two charges for mercury?
1 and 2.
This is
1 and 2.
It'd be the 2.
Mercury.
This is mercury, good. Mercury 2. Alright, 2 charges for copper,
One and two.
1 and 2. So which one is this one?
Two.
It's one. C.
OUS is lower than 2 charges.
Copper
CU
one.
one.
This copper 1. So you positive 1. Okay, 2 charges for cobalt.
2, 3.
Two,
So which one is this one?
three, two.
Or 2.
Remember, OUS is lower charge.
2.
Plumbus, 2 charges for lead.
No,
That's
it's one,
4.
2, and 4.
1 and 4.
2 and 4.
2 and 4.
Which one is this one?
This
Two.
is the,
This
this
is-
is 2.
Yep, this is 2.
Lead 2.
PV positive 2.
Heat blaster.
2 charges for chromium.
2, 3.
2 and 3. So this is the lower of the 2
Chromium,
charges.
two.
Chromium 2.
So you are positive 2. 2 charges for tin.
Oh,
Two and
2 and
four.
4.
2 and 4.
This is.
So this is
Used to be called stannum.
Stanius.
Stanius.
Stannus.
Stanius.
Or tin 2. Carbide is what?
Negative 4.
Group 14, negative 4. Mercurus. Well, the 2 charges for mercury.
This would be
This is
negative, or this would be 1.
HG subscript two.
Plus one.
Positive two.
This is that weird one, really weird one.
Plus 1.
It's mercury one.
It's mercury 1, but it's
HG subscript two.
Hg2 positive 2. What's different about this one, it has a subscript 2 down here. PV positive 4, 2 charges for lead.
It's two and
This
four.
one starts with a P. It's like
4.
Two.
Used to be called plumbum.
Plum, yes.
Plum-
Plumbus.
Plumbic.
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 Not S.
So lead 4 or plumbic. 2 charges for manganese.
Two and three.
And 3. Which one is this one?
2.
Two.
2.
And then
Manganese
two.
two.
And then
Manganese
and then
two.
two.
Manganese 2. Fe positive 3, 2 charges for iron.
Two and three.
So which one is this one?
Ferric.
This is iron 3 or ferric. 2 charges for cobalt.
It's cobalt.
2 and 3. Cobaltic.
Very good. 2 charges for lead.
Oh, this is 2 and 4.
2 and 4.
This is
4.
PV
4.
positive four.
Lead 4. Nitride.
Oh.
Negative 3.
Group 15.
Negative three.
So this is negative 3. C negative 4.
That's same thing, isn't it? Carbon?
Carbide.
Carbide.
Carbide on that? Not carbon.
And stannus, what are the 2 charges for tin?
SB.
2 and 4.
2 and 4.
2 and 4. Which one is this one?
SB positive
Two.
two.
SB positive.
SN.
2.
Tin
Or
2
SN.
or SN positive 2.
Would be it. SB.
SB is antimony.
Yeah.
Alright,
8.
good. You guys feel comfortable with it?
I mean, I wouldn't say comfortable totally, but
Now, the thing is, right now I'm planning on having a quiz, knock on wood here, the day before we go on break.
hopefully we're there.
Yeah, hopefully we're still here. Now,
Are you-
if by any chance we find out that we're gonna be unfortunately quarantining earlier, if we have to, I'll move it up to Monday. Okay, I don't like doing that, but if we need to, I'll try doing that, yeah.
What do you think's gonna happen? You think we'll go sooner, or?
It's 50/50.
I don't know. I don't like to speculate, I just,
Go with it.
I'll
Yeah.
ask Mr. Garrett.
hmm?
I'll ask Mr. Garrett what do you
Yeah.
think?
It's like snow days.
Yeah.
If we're here, we're here, if we're not, we're not.
You don't know
So,
when it's gonna happen.
we spend too much time and energy worrying about things we have very little control
My
over.
best friend's my
Yeah.
one.
Okay,
Zach called 2 yesterday.
so, let's see here.
You can FaceTime people.
Alright, if you would, go ahead and get your notes out. They're recording? Good. Alright, so this is the notes here.
Actually, 2.5 hours until
Okay.
we actually get to play. Hopefully it's like a quarter of KP.
Alright, now, alright, if you look up here, please. So whenever you're writing out a formula here, the symbol are always written out first, and then if you have two or more of that element, you're gonna write a subscript after it. You don't write ones down in chemistry. In other words, like water, H2O. H2 means what? Hydrogen. Okay, you have two hydrogens. O means you have
One oxygen.
one oxygen. What you do not write is H2O1.
So it's like math. You don't put the one next to the X in math.
Right, exactly. As a matter of fact, a lot of stuff you're gonna be seeing here is very similar to what you do in math class. Alright, now, so for example, if you look up here, again with H2O, how many hydrogens do you have?
Two.
Two. How many oxygens?
One.
One. And again, you don't put one down, because as soon as you write down the symbol, that automatically means you have at least one. If you didn't have it, then you wouldn't be putting that symbol down anyway. Okay, so only if there's two or more do you put a subscript after it. But it always comes after the element. Or like carbon dioxide, how many carbons do you have? One. How many oxygens?
Two.
Two. Okay. This is baking soda. So how many sodiums are there?
One sodium, one
One hydrogen. How many carbons?
Three.
And three oxygen.
Three oxygen.
Okay. You don't write Na1H1C1O3.
Too much.
Yeah. This is rust. How many irons are there?
Two.
Two. How many oxygens?
Three.
Okay. Now later on, we'll be getting into ones like this. How many alumins are there?
Two.
Two. Now, this next part here is very similar to your math class. If I didn't have this 3 down here, pretend I can cover it up here. It's kind of hard to do when the light's shining on it. But if I didn't have this 3 down here, how many carbons would there be?
Three.
Without this 3 here, I would have 1. And with this, and how many oxygens would I have?
Three.
3. But with the 3 up here, it's just like in your math class.
6 oxygens, 3 carbons.
Spin it over here.
Yeah.
It's the same thing as doing this.
Distributed properly.
Yeah. What you're doing is this.
So you have 9 oxygen,
So how many carbons? This is your carbon, and this is your oxygen.
3 carbons,
You would have 3 carbons
and 9 oxygen.
and 9 oxygens in a process. Okay?
That's pretty sweet.
But you're gonna see a lot of stuff that is many times is similar to what you see in your math class. We're just kind of using some symbols along the way. So you have 3 carbons and 9 oxygens. Again, you're just distributing that 3 to everything inside the parentheses here.
So why do they have to put it in parentheses and put the 3
Okay,
outside?
now, there's another part to this. This is one of your polyatomic ions. This is a group of ions working together to make, they have a common charge to it. So another way of also looking at this is 3 carbonates.
Oh, okay.
That's one of your polyatomic ions, CO3 -2. So you
instead
have
of
3
writing-
groups of carbonates.
So they're doing it, instead of writing out CO3, 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 they're just making it shorter basically?
Yeah, what they're doing is, let me see if I can bring it over here. I'll find what's in the frame. This is particular aluminum carbonate. Basically, it's kind of like you have 2 aluminums attached to it, and then you have a carbon, which is attached to 3 oxygens. This is not exactly right, but it's pretty close to it. It's kind of like that. So you have a CO3, another CO3, and a third CO3. Okay, so this is you have 3 carbonates attached to it. Or if you go by individual atoms, you have 3 carbons and you have a total of 9 oxygens altogether. That make sense?
Yep.
Okay. Alright. Yeah, not quite the whole thing in there. Here we go. I need a cameraman.
I got you.
Is that what you do in
I used to,
VidPro?
I used to do this, I did that for like 2 or 3 years.
Okay, so now, how do you go about naming the compounds? Naming the compounds is real simple here. You name the positive ion, you name the negative ion. That's it. Now, when you're making a compound, you have no there is no charge to the molecule or compound. They become electrostatically neutral. So, when you're doing this, for example, if you have something like this, NaCl, what's Na positive one called?
Sodium.
Sodium, it's a group one.
Oh, is it?
Sodium ion.
It's a sodium ion, okay? What's Cl negative one called?
That'd be chloride.
Chloride.
That's a chloride ion. Now, because this becomes, when these two join together, this becomes electrostatically neutral. In other words, there's no longer a charge to this. So the positive and the negative, they cancel each other out. So what you end up doing here, this is no longer an ion anymore, so you drop the word ion from both names and it becomes sodium chloride. That's table salt,
Oh, that's sweet.
okay? That's the reason why we don't call it sodium chlorine, table salt, we call it sodium chloride. And that's the reason why we call it sodium chloride, because it's a sodium ion and a chloride ion.
So do they come up with a lot of like the names for these? Like instead of sodium chloride, they say salt. Do they like come up with those based on how they found them or the name of the?
I don't know. Table salt is a common name, but the problem is, what we'll be getting into this in this chapter here too, is the term salt is not, the actual definition of a salt is not what you think of, like what you always put on food, salt, okay? This table salt, this is what they refer to as table salt. Chemically, it is a salt. But the thing is, there are literally tens of thousands of different types of salts. Only a few of them are edible. Most of them are very toxic.
Yeah.
So for example, like sodium cyanide,
Sounds toxic.
Yeah.
No, it's not toxic at all, it only has cyanide.
yeah, that's what they used to use to put people to death. That's a salt. Yeah, definitely don't wanna put that on your fish and chips or anything like that. You know, if you have like copper sulfate, that's a salt. You know, and that is again, something you definitely don't wanna put onto your food here. So, we'll get into exactly what is the definition of a salt a little bit later on here, but not all salts are edible. Just a handful of them are. Okay, now, something like this, Mg positive 2, what's that called?
Manganese.
Or
Group 2.
Oh, so it'd be a
Magnesium.
magnesium ion.
That's magnesium, it's a magnesium ion. Now, even though there's a subscript 2 down here, that doesn't matter. You just go by whatever ion you have. What's F negative 1?
Fluoride.
That's a fluoride. So the name for this compound is magnesium fluoride. Okay? There's another one. What's Fe positive 2?
Would that be, that's
Iron.
ferrous?
It goes by ferrous, or it also goes by
Iron.
iron,
Ion.
Iron 2.
iron 2 ion. So this is an iron 2 ion. What's Cl negative 1?
Chloride.
Chloride ion. So the name for this compound is called
Iron chloride.
iron 2 chloride.
Oh, sorry.
Or, what's the other name for it?
Ferric chloride?
Not ferric.
Or ferrous?
Ferrous
This is ferrous chloride. If this was a positive 3 charge, then this would be called ferric chloride. Or iron 3 chloride, if this was a positive 3 charge. We'll get into why is this a 2 down here. We'll go over that here in a little bit. Everyone follow with this so far?
Oh, yeah.
So it does not matter how many of these you have, you just go positive ion, negative ion, that's it. No matter what the subscript is down here. Alright? Now, this part, we're gonna be doing a lot of. This is what, a good portion of what we're gonna be doing for the rest of the year is gonna be this part right here, alright? Whenever you're writing out an ion to make it into a compound, you always write the positive ions first. Positives always come first. Just like the names, positives always come first. You write the negative ion last. Thing is, molecules, they're neutral. You have to make the charges balance out. You cannot go and change the charge itself. But what you can do is change how many of each ion you have. So you want just the number of ions until finally the charge is 0. But this last rule is also important here too. You want to make sure the subscripts are always the smallest whole number ratios. Okay? So, let's see those rules again. So let's say you have Al positive 3 and S negative 2. Tell you what, this will be easier, take out a clean sheet of paper here. I'm gonna work this out on the board.
Yeah.
Actually, I haven't.
Okay.
No.
Okay. Now, when we're first doing this, I'm gonna show you, like, breaking this down to very small steps. Later on, we'll get to the part where we're gonna be skipping over a lot of these, like, small steps, and just kinda go directly to the answer. But once you kinda get the grasp of this, there's a lot of steps we could actually be skipping over here. So, first thing what you do is write down both items, AL positive 3, S negative 2. You always write the positive first, followed by the negative. If you ever see the negative first, you'll need to flip it, okay? Now, this whole thing, if I'm making a compound out of this whole thing needs to be neutral. And right now, if you look at the charges, overall, this has a positive 1 charge. I cannot change these charges up here. What we can do is change how many of each one you have. So what's a number that both of these can go into? 6. So I need a positive 6 and a negative 6. So the way to get a positive 6 is I need another aluminum. So right underneath you write down another Al positive 3.
So 2 aluminum, 3 sulfides.
So another S negative 2 and another S negative 2. Go and write that down. Like I said, we're just kind of doing small steps here. Later on, we won't be doing all this. But when you're first learning it, I want you to be able to visualize what's going on. All right, so right now, 2 positive 3s gives me a positive 6. 3 negative 2s gives me a negative 6. Overall, this whole thing is now neutral. But this is not how you write it out. So write this down again, Al positive 3, S negative 2. This is what now you're going to be adding subscripts. You count how many each one do you have. How many lumens do we have?
2.
2. So you put a subscript 2 down here.
3 sulfides.
And you have 3 of the sulfides, so you put a 3 down here. Now, just the way, eventually we'll get to the point where we don't even do this part up here, okay? But one thing I also want you to get in the habit of doing here is taking this number down here, multiply to the number that's to this charge. What's 2 times positive 3?
6.
So you have a positive 6. So we'll put a positive 6 up here. 3 times negative 2 is?
Negative 6.
Negative 6. So just kind of check the charges. Positive 6, negative 6, the whole thing equals 0. That is your formula, Al2S3. Now, a lot of times when you see this written out, you will not see charges. I always want you to write your charges down, okay? It's good practice for you to write down the charges. It helps you kind of learn your ions a little bit faster here. It's also kind of a good way to check your work. Many times you'll see this written out as simply as Al2S3. That's where that comes from. But I don't want you doing that. Leave the charges on there. Now, for the name of this, you name the positive ion first. What's Al positive 3? It's an aluminum ion, it's group 13. What's S negative 2 called?
The aluminum sulfide.
So this is a sulfide ion.
Wait.
So this compound is called aluminum sulfide. Make sense?
Yep. Yeah.
You trying to figure something out here?
No, I was just looking at my paper.
Okay. All right, let's try another one here. Well, let me show you something here too. With that last roll, where it says make sure this, if necessary, adjust the subscripts to lowest whole number ratios. And I've had students do this before. They're working on something like this, say Al positive 3, S negative 2, and they're saying, okay, I need something where both of these can go into here. So you go Al positive 3, Al positive 3, Al positive 3. So I have positive 12, S negative 2, S negative 2, S negative 2, S negative 2, S negative 2. 1, 2, 3, 4, 5, 6. So I have a negative 12 over here. So if I do this, I have Al positive 3, S negative 2. I have 4 aluminums, and I have 6 sulfurs. And if you check, it's neutral. Okay? Problem is, look at this. 4 and 6. What was it?
You can reduce it down.
You can reduce it down. So this becomes 2 and 3, Al2S3. So positive 3 and a negative 2. The charges will not change. Okay? You can change how many of each one you have here. So this is the correct way of writing it. This is not. You always want to make sure these are the smallest whole number ratios when you're doing that. Does that make sense?
Yeah.
Yeah.
So you just wanna like treat it as like like trying to get two denominators of a fraction to be equal to each other, right?
Did I say again?
Like trying to get two denominators of a fraction equal to each other.
Yeah. Very similar to that. And then again, this is one of those things here, when you look at it, it's basically, this is just math. This is kind of your simple algebra math type of stuff here. Hmm?
So I'm taking 2 math classes.
Yeah. You take physics, it's like taking a whole nother level of math again, which is awesome.
I'm sure physics has a lot of
Just a little bit. And when I mean a little bit, I mean a lot.
yeah.
Okay, let's try this one here. We'll start with some simple ones here first. Ca positive 2, Cl negative 1. What's the one number that both of those can go into?
2.
2. Now the thing is, that's a good point. You could also make it 4. But the problem is, when you got to your final answer, you would have to reduce it down after that. But that still would have worked. But 2 is another one here. So we already have a positive 2, but we need a negative 2.
Put 2, Cl2.
We need another Cl negative 1. So I have Ca positive 2, Cl negative 1. What I put after the calcium?
Nothing.
You don't put a 0 down. Yeah, you don't put anything down. What I put after chlorine?
2.
Put a 2 down here. Okay. Name for it would be what? Calcium's in group 2.
Calcium ion, chloride. Calcium chloride.
Calcium chloride. This is sometimes referred to as a desiccating agent. It's kind of similar to, if you're, like when you get like a dope of like a thing of like vitamins, or if you buy a new pair of shoes, you have like this little tiny pillowcase, and it's kind of annoying little granule type of stuff they have inside of it. That's a desiccating agent. And some stuff, they would use this. Thing is, this can also be toxic, so this is not good to have around food or little kids here, but this is also good at pulling moisture out of the air. Yeah, don't do that. This is also what they put on road salt. The stuff they put on the snow and something like that. This is what helps to melt the snow. So this is calcium chloride. All right, let's try another one here. Actually, we're almost out of time, aren't we?
Yep.
All right, we'll continue this on tomorrow. Study your ions.
I like this one. What about you, Lauren?